All right, so we are continuing section 8.2. We're going to look at another series here. This is actually another telescoping series, so let me give you a moment to copy the example down. Okay, so once again, this is a, hold on here, let me move my, this is telescoping series. And we want to know what its sum is. So, of course, the 3 here, naturally the 3 we can pull out in front. Okay, we can pull that out in front of the summation. And I'll note also that this summation starts at n equals 2. And that's fine. You know, series don't always have to start at n equals 1. They could start at n equals 0 or n equals 2. It's really, what matters in terms of the, well, I mean, it's fine. It's fine. So let's see how we, let's see how we find the sum. So just like before, go to the solution here, like the previous example that you saw. To find the sum of the series, I'm going to define my nth partial sum. Okay, I'm just going to define it as I goes from 2 to n. Okay, and I'll factor the 3 out. And that gets us here. We have to use partial fractions on this 1 divided by I times I plus 2. So partial fraction expansion, you see it there. And what we'll do is multiply both sides of the both sides by I, and I times I plus 2. That's the least common denominator. And, you know, we do the partial fraction expansion math, and that gets us down here. Okay, let me give you a moment to catch up. Okay, so now we have to solve for those constants, those A and B constants. So in this equation here, the constant 1 would have to equal the 2A, and the A plus B would have to equal 0. And so this gives us two equations, a plus b equals 0 and 2a equals 1. So therefore, a would have to be a half, and it follows b would have to be a negative half. And so now our nth partial sum will equal this expression here, 3 times that summation. The 1/2 is the a. And I guess if I wanted to be a little bit formal, I could write this as plus negative a half. The negative 1/2 is the b. Now that we've gotten down here, what are we going to do with the sum, this nth partial sum? What do we have to do in order to figure out a formula that gives us the nth partial sum? What do we have to do with this series? Well, we have to telescope it out, expand it out. So, you've all seen in the movies, telescope, the movies, the sailors use a telescope, it collapses and then it expands and you can look through it and you can see far away. You've all seen a telescope, right? And so we're gonna take this nth partial sum and telescope it out so we can get an idea of what the pattern is and what the sum will be. So let's, if we're good, let's go to the next page. So, okay, here's our nth partial sum. And I'm gonna suppose that n is greater than or equal to 4, just because I'll need that in order to get my answer. I mean, the nth partial sum, we're going to look at the limit of the nth partial sum as n goes to infinity. So what I've done here is I've written out the series. I've written out quite a few terms down here. Now, let me give you a moment to catch up here, okay? Let me give you a moment to copy that. Please let me know if you have any questions. I will mention one thing here. So remember, the nth partial sum was equal to 3 times this summation here. And I can factor out a half from there. And so the half can be, this half can be brought out front of the summation sign. So that's how we get the 3 halves here. That's just from 3 times a half. Okay, now what's being said here is that the summation, this entire sum here is equal to a half plus a third minus 1 over n plus 1 minus 1 over n plus 2. Okay, now how do they get that? How do we deduce that? Let me go ahead and go to the whiteboard and I'll show you. This is important because you'll see these kind of problems in your homework, and you know, I want you to be comfortable with them. So let me just hold on here. Okay, let me start with S sub 4. So S sub 4 is shoot, hold on. I got to get that font down. I don't know why it gives me 5-point font. I think it should do, I think 3-point font is a better starting place. But all right, so fourth partial sum is 3/2 times, okay. So we have a half minus a fourth plus a third minus a fifth. Okay, so a half minus a fourth is when I was equal to 2. When I equals 3, you have a third minus a fifth. And then you have a fourth minus a sixth. That's when I equals 4. Yeah, that's fine. That's fine. So, all right. So even though, like, normally you think of S sub 4 as the sum of the first 4 terms, but because n started at 2, S sub 4 is the sum of the first 3 terms. I mean, we don't need to really get too worried about that, okay? Now look what happens here. We have some terms. Let's see, what cancels here? What cancels? What fractions cancel here? The fourths, negative a fourth, positive fourth. That's right, Ange. And so what you're left with is you're left with 3/2 times 1/2 plus 1/3 minus 1/5 minus 1/6, which is 3/2. So let's keep in mind we have a S sub 4 here. So that equals 1/2 plus 1/3 minus 1 over 4 plus 1 minus 1 over 4 plus 2. See that? If we did, let's do one more. If we did S sub 5, okay, if we did S sub 5, the fifth partial sum is 3/2 times, okay. So we have a half minus a fourth plus a third minus a fifth plus a fourth minus a sixth, okay, plus a fifth minus a seventh. And let's see what terms cancel there. The fourths go out. What else? What other terms cancel? The fifths, that's right. Fifths go out. That's right, Jan. And so you get 3 halves times a half plus a third minus a sixth minus a seventh. Well, that's 3 halves times 1/2 plus 1/3. Let me see here now. This is S sub 5, right? So here's my little sub 5 here. Okay. 1/6 can be thought of as 1 over 5 plus 1. And 1/7 is 1 over 5 plus 2. See that? So we're getting a pattern here. We're detecting a pattern. You see that? So you have when you had S sub 4, you had the 4 plus 1, 4 plus 2. S sub 5, you have 5 plus 1, 5 plus 2. So this might lead you to say then that the nth partial sum will equal 3 halves times a half plus a third plus 1 over n plus 1 plus 1 over n plus 2. See that? That's how you have to do these problems. That's how you have to do these problems. You have to deduce the pattern by looking at a couple of specific partial sums and seeing if you can find the pattern. Are there any questions on that before I go back to the to finish the example off?
Professor, isn't
Yes,
it isn't it isn't it minus 1 over n plus 1 minus 1?
Oh, I have an error, don't I? Yes, thank you. Good catch. Hold on. Good catch. Good catch. I do have an error here, don't I? Thank you, Ange. These here, these aren't pluses. These are minuses. Thank you. Okay, better? Thank you. Excellent. Are there any other good questions? Excellent. Thank you, Ange. All right. Well, then that being said, let's go back to the example here. Okay, so now we are okay. We are okay in this problem. We should be okay now. Going from here to here. We should be all right. And so the partial sum now, okay, the partial sum S sub n, we can combine the half and the third to get 5/6. Okay, and then I can distribute the 3 halves across the 3 terms. And that's going to get me then for my nth partial sum. Nth partial sum is 15 halves minus 3 halves times the quantity 1 over n plus 1 minus 3 halves times the quantity 1 over n plus 2. And now we're ready. Now we're ready to take the limit. We're ready to take the limit of that nth partial sum. Are there any questions up to here? All right. Well, let's finish the problem then. So here we are then. What's the sum of the series? The series is going to converge, and the limit as n goes to infinity here of all of this expression is just going to be 15 halves. The 1 over n plus 1 goes to 0, and 1 over n plus 2 goes to 0 as n goes to infinity. So our series converges, and its sum is equal to 15 halves. So the telescoping series problems are nice because it's another way to find a sum of a series. You look at the partial sums, the sequence of them, and show that the partial sums approach a limit, and that limit is the sum. In this case, 15/12. There's a whole course that deals with series and sequences. I mean, you're learning them in chapter 8, but I took a whole course on that. There's a whole book that talks about series, like series, infinite series. It's by, I believe the name's Howard Knopp, Knopp. And it's really fascinating, truly fascinating. They're a lot of fun, really. All right, are there any questions on this problem before I stop the recording? Who's feeling comfortable? Maybe give me a thumbs up if you're comfortable. Okay, Taj and Nathaniel and Ange are comfortable, and Jan and David. Okay, very good. All right. Well, if you're good, let me stop the recording here. And we've now section 8.2. We're done with that section, and we're going to talk a little bit about section 8.3. So excellent.